Hi guys, it's Mrs. Ramira. Go ahead and pull out your note sheet for fractions with like denominators. Looks like this. And we're going to get started talking about how to add and subtract fractions when you have the same denominator. So before we get started, let's review real quick equivalent fractions. We talked about this last chapter, but remember that word equivalent, it actually means equal. So I'm talking about two fractions that are equal to each other or have the same value. So for example, I have the fraction 3/5. To find an equivalent fraction, as long as the fraction has the same value, it's going to be the same. And we talked last chapter about how we can make equivalent fractions. We can multiply by any number we want as long as we do the same, as long as we multiply the numerator and the denominator by the same number. So for example, if I multiply 5 times 2, then I have to multiply my numerator times 2. So 3 times 2 is 6, 5 times 2 is 10. 3/5 has the same value as 6/10. So let's visit this concept of equivalent fractions using the pattern blocks so you can get an idea of what I'm talking about. I have a hexagon here, and I only used one piece to make it. Over here, I have a hexagon, but I split it. This is 1/2 of a hexagon, and then over here is the other half of a hexagon. Once again, I have the hexagon, but I broke it into 3 pieces this time. 1/3, 2/3, 3/3. And then here, I broke it into 6. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So when we talk about equivalent fractions, and I say that they need to have the same value, what I mean is this hexagon, even though I broke it into 2 pieces, it is the same as the original hexagon. Over here, even though I broke it into 6 pieces, I'm not going to try and move it, sorry guys, is the same size and value as that hexagon. Over here, even though I broke it into 3 pieces, it's going to be the same as the original hexagon. So to see what that looks like written out, my whole hexagon is equal to 2/2 when I cut it in half. It's equal to 3/3 when I cut it into thirds, and it's equal to 6/6 when I cut it into 6. These are all equivalent to each other. So looking more closely at my hexagon when I cut it in half, say I want 1/2 of my hexagon, and I want to find out what could be equivalent to 1/2. Well, looking down at our triangles, I want what is the same as half that hexagon. Well, 1/2 is going to be the same as 1, 2, 3 triangles. Now remember, a triangle is 1/6 of the hexagon. That's because 6 of them make the hexagon. So I can say 1/2 is the same as 3/6. I took 3 of the parts when I break it into 6. Just like we did on the board, notice to get the equivalent fraction, 2 times 3, that gives me 6. Whatever I multiply the denominator by, I have to multiply the numerator by, so 1 times 3 is 3. So 1/2 is equivalent to 3/6. So one more example with the pattern blocks. Say I have my hexagon, it's broken into 6 parts. And so what if I want to find out what 4/6 plus 3/6 would be? Now remember, when we add, the bottom number, the denominator, doesn't change, and this is why. Because regardless of how many triangles I have, this triangle will always be 1/6 of a hexagon. So that never changes. The size of the triangle never changes. So the denominator will always stay 6 as long as I'm adding. So the first problem was 4/6. So I'm going to take 4 triangles, And the second part of my problem was 3/6. So I'm going to add 4/6 plus 3/6 together. And do you see, because the denominator is 6, all the parts are the same. And so when I add it together, that creates one whole, and then I have 1/6 left over. So I have 1, 2, 3, 4, 5, 6, 7. So my answer over here will be 7/6. But like we saw with the pattern blocks, 6 of those creates a whole, and I have 1 left over. So over here, I'm going to write 7/6, but it's the same thing as 1 and 1/6. So now that we've looked at some examples with the pattern blocks, let's go ahead and try example 1 on your note sheet. So remember, the key thing with adding fractions and subtracting fractions is that the denominator is the same. We need to be talking about the same size parts each time. So in example 1, 4/12 plus 7/12, my denominator is 12 in both of these fractions. So that means I can add. Remember, when we add fractions, the size of the part doesn't change. What changes is how many of those we have. How many parts do we have? If we have 4/12 and then I add 7 more 12ths to it, I'm going to have 11/12. We're going to look at number 2. Number 2, I have 1/6 plus 5/6. My parts are the same. I'm talking about the same size part. I have one of them, and then I'm adding 5 more, and so that will give me a total of 6 parts. So say we're talking about slices of pizza. If I have a pizza and I break it into 6 slices and I eat one, then I come back later and I eat 5 more pieces. 1, 2, 3, 4, 5. I ate 6 out of the 6 pieces of pizza. So that is equivalent to 1 whole pizza. Now, sometimes when we add our fractions, we're going to end up getting an improper fraction. So rewrite all improper fractions as mixed numbers so we can see your answer according to how many wholes you have and how many parts you have left over. So for example, number 3, if I have 7/9 and I add 5/9, my answer is 12/9. Well, I want to change that to a mixed number. So remember, to do that, I need to divide. 12 divided by 9. So 9 times 2 is 18. That's too many. So 9 can only go into 12 one time, and now we need to count up to see what our remainder is. 9, 10, 11, 12. So I have 3 left over, and everything's still broken in to 9 parts. My denominator doesn't change at all. So now let me show you subtraction with the pattern blocks quickly. We're still talking about 6 parts, and if I have here 6 plus 1, so I have 7/6. If I want to subtract 4/6 from that, then I would just take away 4 parts, because again, we're talking about the same size part each time, so I just need to take away 4 of them. So 7/6 minus 4/6 leaves me with 3/6. So now that we've done that, look at example 4. Find the difference of 7/8 minus 3/8. They both have 8 in the denominator, so that means we're talking about the same size part. So if I have 7/8 minus 3/8, I'm still going to have 8s in the denominator. I'm just going to subtract how many I have. So 7 minus 3 is 4, and so my answer is I'll have 4/8. Now we are going to be moving into always writing our fraction in simplest form. So for right now, this might be an acceptable answer, but what I want you guys to do is start to recognize that, hey, wait a minute, 4 goes into 4, and wait, 4 also goes into 8. So we're going to simplify this fraction by dividing the top and the bottom by the same number. Remember, it has to be the same number. So 4 divided by 4 is 1. 8 divided by 4 is 2. So 4/8 is the same as 1/2. We just use the 1/2 because it's in simplest form. It uses the smallest numbers possible. All right, looking at the word problem, a circus has 10 seating sections. 8 sections are filled for the first show. 6 sections are filled for the second show. How much more of the entire seating arena is filled for the first show? So the circus has 10 seating sections. So we're always talking about 10 sections, regardless of where we're at, whether it's the first show or the second show. We're always talking about 10 seating sections. That doesn't change. So the first time, 8 are filled up, and the second time, 6 are filled up. The question is asking us how much more of the entire seating area is filled for the first show. So to figure that out, we're going to subtract the 2. So we're still talking about the 10 seating sections. That doesn't change. But the first time, 8 of them were full. The second time, 6 of them were full. So for the first show, 2 more sections were filled. So once again, you see 2/10 as the answer, but hopefully that stands out at you as, whoa, wait a minute, they're both even. So I can divide the top, divide the bottom, and my answer is 1/5. So I'd like you guys to go ahead and complete page 219. It's in your textbook, and I want you to use the grid paper so that you can do one problem per box for now.